Hi, today I'll be coding the design right here, which isn't mine. I don't do design at all. I'm a tech, not an artist. I'm not capable of doing design, just to have that clear, because a lot of people still label me as a designer, which leads to even more people wanting me to do design, and that is terribly frustrating and disheartening. Anyway, if you're a patron on Patreon, then you may have already seen this, maybe even voted for it to become the topic of a video, so hooray, we're doing that today. It's something that's a lot more challenging for me than my normal simple geometric stuff, where almost everything is generated logically within a loop and only a small amount of code is required. But hopefully I'll be able to do a decent job, and it won't take me all day, because as I said, this is a lot more complex than geometric demos. So wish me luck with it, and let's jump straight into the code. Okay, now here we have an array of plans, and for each of the plans we have a name, description, cost, list of features, list of colors. Now the first thing that we're going to do is get the number of plans, which is basically the length of the array. So the length, okay, and now we're going to have a loop for I going from 0 all the way up to n, increment this I, and create an article element at each step. So this article is going to be a plan, and for each we're going to have a header, we're going to have a main section where we're going to have the features, and we're going to have a footer where we have that call to action button. So I believe that was view plans and prices, so something like that. Okay, now the next step here, we are going to have a heading, so that's going to use the name. By the way, let's get the current plan. That is going to be at index I. So the current plan is the one at index I, and here we're going to have the plan name. And for some reason my laptop fan is going crazy. And we're going to do the same for the description and cost. If I can spell that right. Okay, now here we are going to have a list and another loop. So for key in plan features, right? For each we are going to have a list item. Let's see that. Okay, now we have the key. We're also going to get the value for each. That's going to be plan features of key, right? And then you can see how in this list of features we have some that have a number value and others that have a Boolean value. So let's see if the value is a Boolean one, and we're going to call this a boo because it also has 3 characters and that makes it align nicely. Okay, so if type of value is the exact same as type of true. By the way, I am going to link to a reference for the type of operator, because I'm not really sure where everybody's JS level is, and yeah, I mean, I didn't learn this, how to use an HTML preprocessor. I basically just saw other people using that, and I just copy-pasted their code and started modifying. And in this case, it's just JS. You just escape it with a dash in front, and that's pretty much it. It quacks like a duck, and yeah, you feed it like a duck. You feed it JS code, whatever. So yeah, that's pretty much all there is to it. I mean, all I do about it. So here, if we have a Boolean value, then we are going to put the key. Otherwise, we are going to put the value in there. Okay, so let's see that. Okay, now if we have a Boolean value and that is false, as it is the case right there, okay, then we are going to have a disabled attribute. But in other cases, we don't have this attribute at all. So only if we have a Boolean and this Boolean is false. Otherwise, we don't have this attribute at all. And maybe you're wondering what's the operator precedence, and yeah, this is correct. This is going to work just fine. But if you're worried about that, you can just put that first part within parentheses. Now another attribute we're going to have here, but only for these that don't have a Boolean value. So if the value is a Boolean, then we're not going to have this attribute at all. Otherwise, we are going to set it to the key. Okay. So now that we are done with that part, there's just one more thing, the colors. So we're going to take that list of colors, and we're going to pass those colors to the CSS as custom properties. So we are going to take plan colors and map that array. So we are going to have the current color and the current color index, right? And we map each item in this array to C, and it's going to get the index K, the color index, and the value is going to be the current color. Okay, now having this in the style attribute right here, we are going to join that array with a semicolon, and this should do it. Let's look at the compiled HTML, and you can see those colors, right? You can see that disabled attribute for some of the list items. You can see that other attribute for the list items with number values. Okay, so we are done with that part. Let's move on to the CSS. And we are going to start with a few basic things about layout, basic reset, stuff like that. So HTML, body, article, also for a footer, because we're going to want to spread out. And let's also do it for section. Okay, so section, that's supposed to be comma. Display grid. Okay, and like a basic reset, we are going to have margin 0, padding 0, 0. Okay, color, inherit, font, inherit again, right? So on the body, we are going to have something like this. We're probably going to tweak this stuff. Now for our plan elements, we are going to give them a background so that we can see some stuff. Obviously it's not going to be black. Let's make it something lighter. Okay, and we are going to set a base width, and let's say it's going to be something like 16 ems. So that's going to be our width right there. Okay. Here we are also going to have justify content center, like that. Okay, it's starting to look like something. Then we're going to have header, right? Text line center. Okay. Now for the name and for that button, so we are going to have text transform capitalize. Okay, and then let's look a bit at the colors. For the name, for the cost, and for the button, we are going to have that light color, the secondary color, and everything else is going to get the primary color. So name, cost, so that's going to get color which we already have there, the light one, and then body, before and after, and you are going to see now why I'm doing that. So why am I doing it for a before and after? Well, for example, for the cost, well, we are going to want to have the currency in front and per month after, and yeah, those are going to use before and after pseudo elements. And also there we're going to use after pseudo elements, all that good stuff. But for now, there's something else that I'd like to do. So actually, I'm going to take body and section, and for both of these I'm going to use that justify content center. Okay, that looks better. So something else I'm going to want, some relative font sizes for the name, description and cost. So name, relative size, let's say it's going to be 3. Description, relative size, let's say it's going to be 0.8. And for the cost, let's say it's going to be 1.25. Now we are going to take name, font size, name, relative size times 1m, and then we're going to have the same for description and for cost. So this is going to be description and this is going to be cost. Now for cost, we said we're going to add those pseudo elements, right? So we're going to have before, and it's going to get content, and then similarly we're going to have an after. And now you can see how that's a dark color, even though the actual cost, the number, is the light color. This is going to be per month. Okay, and something very similar we are going to have for these two first list items. Right, so for the after, we are going to use the attribute. So the attribute value for the content value of the after. And let's add up a space. So like that. And let's say here we want a different color. So the darker of them. Now that messes up the marker, you can see there. So let's also add marker right here. Okay, and that fixes it. Okay, you can see how we're starting to see something that's not horribly hideous. Let's also have a base line height. And this is the one that we'll be using right here. So let's change that to the baseline height and get the height for the header. So we are going to compute it out of its components. That's why we had those relative font sizes. So let's say that the height of the header is going to be that border. So let's also set that. We're going to have a base border. Let's say 1m, right? And then we're going to have the height occupied by the name, the height occupied by the description, plus the height occupied by the cost, everything doubled. Like maybe you can see how the line uniting those corners passes through the middle of the cost. So maybe we're not going to have the full height of the cost, maybe just a fraction of it, and then double everything. But yeah, basically the head height is going to be doubling base border, and then we are going to add name relative size plus description relative size plus cost relative size times base line height times 1m, right? And this is going to be the height of the header, and we're also going to have the before and after pseudo elements of the plan. We are going to have them underneath the header, so they're going to get content, because otherwise nothing is going to show up. And here we are going to have header before and after, right? And they are going to get, they're going to be in the grid cell at the intersection between the first row and first column. So basically the header, the before and the after of the plan element are going to be stacked one on top of the other. So now we're going to set the height here to that header height, okay? And we are going to set a border which is going to be solid, that base border. Let's see it. And you can see how when I added it, the height increased. Let's just go back to that. And you can see how the text jumped up. And that's because the border gets added to the height. But we don't really want that. We want it to be included in the height. So we are going to fix that with box sizing border box. Now, this gives us the box whose height we refer to when we set this height property, okay? So by default it's content box. So by default this height is going to be the height of the content box, and then the padding and the border get added to it. If we set box sizing to border box, then this is going to be the height of the border box, and the border gets subtracted from it, okay? The border is included in it. Okay, so now having done this, let's change the color right there and make it white. Let's actually have a different background here. Something like that. Just so that we have, that was supposed to be not black, it was supposed to be white. Sorry. Okay. That is really weird. Why doesn't that look white? Oh, I didn't add. Right. I didn't add it where I should have. Okay, now it should work. And now you can see how the after is on top of the header. So to fix that, we are going to bring the header on top of the after, because by default the header is on top of the before but is underneath the after, and we want it above both of them. And we also don't like how it starts from the very top. We want a bit of space there, so we are going to add padding top equal to that base border. And yeah, I think it is still a bit too tall, and we are going to use 0.5 there, for example, something like that. Okay, so now that we've done this, let's start creating that background, because it's not going to be just that weird pink right there. So let's go back here. You can see this shape, right? And it looks kind of like something we could be able to get with a conic gradient at that point right there. Conic gradient starting from that line, okay, solid up to here, and then transparent for the rest. And then here again, something pretty similar, a conic gradient starting from that line, going up to here, and then transparent. Okay, let me just show you. A conic gradient by default starts from the top, from 12 o'clock. But we can start it from somewhere else, so we have the keyword from a certain degree, so from 90 degrees, and from 90 degrees means it starts from the right, from 3 o'clock, or it can start from minus, from the other direction, from minus 90 degrees, and in that case it starts from the left, from 9 o'clock, okay, and goes like this. So yeah, we can change the axis from which the conic gradient starts. So that's what we're going to do. We are going to ignore the roundings at first, and we're going to create that conic gradient. And we are going to just start with a given angle alpha. And alpha is the angle of this line. So this is the inner part that we want to get with the conic gradient. Inside the border, that's basically the border width there on the sides, and this is also going to be the border width, this is also going to be the border width, that base border, okay? In this illustration right here, they look like they don't have the same thickness, but we are going to use the same thickness because it's just making things a lot simpler. So yeah, all of these white lines here, they're going to have the same thickness. Okay, so let's get back here for a moment. Alpha is the angle of these two diagonal lines with the horizontal. So we are going to start from minus alpha, we are going to go for 2 alpha, and then we're going to have transparency. And of course we are going to place this gradient at that point B right there. But before we compute the coordinates of that point B, let's just get those basics done. I'm not going to use Greek characters here because it would complicate things, but let's say we use something like 68 degrees, and that is going to be our alpha in the drawing. And of course on the drawing it's better to use just one character because otherwise it's going to get super crowded super fast. So just keep those equivalences in mind, and that's pretty much it. Okay, so now we are going to have not linear gradient, what am I writing? Conic gradient. And we finally have autocomplete for this. So we have from minus alpha, then we are going to have black all the way up to twice that alpha, and then we're going to have transparency. Oh, that is not what I intended to do. Transparent, like this. And now you can see how we see through to the background on the plan element, and we don't really want that, so we are going to add just this white right there. Okay, so it's a bit too high up. You can see we don't want it that high up, we want it a bit lower, so we need to compute the coordinates of that B point. So how do we do that? Well, it's going to be a bit of trigonometry. Now here, right, this line and this line, these two lines are parallel, okay, and this line right here is basically crossing them. So that means that this angle right here and this other big angle right here, they are going to be equal. So their corresponding angles, right, you can see however we move these two corresponding angles are going to be equal because we have two parallel lines and this other line crossing them. So no matter how this line changes, these two angles are always equal. And by the way, this angle is also equal to this angle, which means that this angle right here is going to be equal to this angle right here and to this angle right here, okay? So now let's go back here. This angle equals this angle. We know that this angle is alpha, this angle is alpha. And on one side of a line, so around the point we have 360 degrees, and on one side of a line we have 180 degrees. Okay, so alpha plus this beta angle, they're going to add up to 180 degrees, which means that this beta angle is going to be 180 degrees minus 2 alpha. Okay, so this beta angle right here is going to be 180 degrees minus 2 alpha. So this big angle right here, the full angle, equals that angle right there. Okay, now again we have this vertical line splitting the whole thing into two in the middle, and then here we also have a vertical line, right? Two vertical lines, they're both parallel. This diagonal line crosses them both, right? Which means that this angle right here is also alpha, as it is this one. So this angle is alpha. So in a triangle we have in total 180 degrees. So you can see however we change the triangle, the angles add up. And that is a funny effect on drag, which is probably not intended, but this is an old demo, and yeah. Okay, so the angles in a triangle add up to 180 degrees. So in this triangle right here, we have beta plus alpha plus another angle add up to 180 degrees. But beta plus alpha add up to 180 degrees, which means that this angle is also alpha. Okay? So since these two angles are equal, it results that these two edges are also equal. So if we draw a perpendicular from here, from this point C, onto this edge, right, then we split this triangle into two right triangles with the same hypotenuse, with this same edge right here, which means that these two edges are equal. So basically it splits, this perpendicular splits this edge into two. And this also means that it splits this angle into two. So gamma is going to be half of beta. Okay, so gamma is half of beta. Now, we have this line which is perpendicular onto the vertical, so it's going to be horizontal. So this is a horizontal line. This right here is also a horizontal line, right? Which means that this angle right here is going to be equal to this angle right here. So this is also going to be gamma, right? But you can also get it as gamma because in this right triangle, right, the total, the sum of the angles is 180, and this one is 90, which means that this gamma plus alpha add up to 90. But here we have a 90-degree angle. This is alpha, okay, because this is parallel to this one, and this is parallel to this one, so they're basically two angles with parallel edges, so that's alpha as well. So it means that this angle is 90 degrees minus alpha, but gamma is 90 degrees minus alpha. So this angle is gamma as well, which results that this angle is alpha, okay? And we know this edge because it's half the base width. This line, right, this vertical line splits everything into half, so this is going to be half the base width, and we know this angle, right? So it means that we can compute this edge right here, because this edge over this edge gives us the tangent of gamma. So this edge right here is going to be half the base width times the tangent of gamma. So that is going to give us the coordinate of A, which is going to be the head height minus this edge, which is half the base width times the tangent of gamma. So let's now get the coordinates of A, the coordinates of B, but first let's compute beta first. 180 degrees minus twice alpha, so right, and then we're going to have gamma, and this one is going to be just half of the previous one. And then we are going to have the x-coordinate of A. That is pretty simple. So it's, let's go back here. We can either write it as 50% or half of the base width. We're going to choose half the base width so that we don't mix units, percentages, and amps, okay? Then we are going to have the y coordinate of A, which is the header height minus half the base width times, and we're going to need to use tangent. So we're going to import the SAS module, right? So we can have trigonometric functions. So use SAS. Okay, so now, by the way, trigonometric functions are also going to come to CSS. They are already in Safari, so no other browser implements them, so I haven't been able to test, but yeah. Okay, so here we are going to have the gamma, tangent of gamma. So that's the x and y coordinates of A. The x coordinate of B is going to be the same as the x coordinate of A, and the y coordinate of B is going to be the y coordinate of A minus that AB segment. So how much is that AB segment? So it's going to be the y coordinate of A minus this AB segment. Now in this here, if we draw a perpendicular from here, this is going to be the base border width, right? And this angle right here is going to be alpha, because this line is parallel to this other line, and this vertical is crossing them both. So those are two corresponding angles, and they're equal. So that's going to be alpha. So sine of alpha is going to be that base border width, B, over AB, which means that AB is going to be that base border width, B, over the sine of alpha. So base B over the sine. Okay, so now we are going to place our conic gradient at xb, yb. Okay, and you can see how it doesn't look like it's in the middle, and that's because of this tiny little property called background origin, which is padding box by default. Padding box being this box inside the border, right? So outside here, this is the border box, this is the border all around that line, and this inside the border is the padding box. And we've computed those coordinates relative to the border box. But since the background origin is set to the padding box, then all these at positions that we can have in conic gradients or in radial gradients, the background position, the background size, they're all relative to the background origin box, which by default is the padding box. So let me just show you. I wrote this article, so this explains the boxes, the content box inside the padding box, inside the border box, all the different cases where we have padding 0, border 0, padding 0 and border 0. Now we have this example where we have background position 0, 0 and background size 50%, 50%, right? And this hashed area is the border area, okay? And in this case, background position 0, 0 means the 0, 0 of the padding box. Background size 50% means 50% of the padding box. So 50% of the padding box width, 50% of the padding box height, because background origin is by default padding box. Now, if we change the background origin to border box, then the 0, 0 of the background position is going to mean the 0, 0 of the border box. The 50% of the background size is going to be 50% of the border box. And these coordinates, the at coordinates that we may have in conic or radial gradients, they are going to be relative to the border box. So here we're going to set background origin, border box. And now you can see how everything looks much better. Okay. Now we are done with this, and we said that we're going to want another radial gradient, which is going to start from this line right here. So what does this mean? This is a horizontal line, right? So it's at 90 degrees with respect to the vertical. So if we were to start from that horizontal line, we'd be starting from 90 degrees. But we don't start from that. We need to go back by this gamma. So we are going to start from 90 degrees minus gamma, and we are going to go for a full beta angle, and then we're going to have transparency. And we're going to need to get the coordinates of C. But for now, we're just going to place everything also at B, just to simplify things for the moment. So this is going to start from 90 degrees minus gamma, which is A2. Okay, and we are going to go for beta. Let's make this red so that it's a bit more obvious. Oh, yeah, that should have been F. Sorry. Okay, so now this is how it looks if it's at the point B, but we want it at point C. So the point C is going to be the coordinates, the x and y coordinates of the point C are going to be the x and y coordinates of the point B plus the x and y coordinates of the point C relative to point B. So how do we get the coordinates of one point relative to one point? Well, we can consider that this is the point relative to which we want to get the coordinates, right? And it's like we have a circle with a radius, that's the distance between the 2 points, right? So this is the distance between the reference point and the point whose coordinates we want to get relative to the reference point, right? So this is the distance or the radius of this circle. And then we have the angle of this line segment with the horizontal, right? So then the coordinates of this point relative to the reference point are going to be this distance between them, which is called like a radius, the radius of this circle, times the cosine for x and times the sine for y. Okay, because this is a right triangle, right? And we have this angle, and this is the y coordinate, so opposing the angle, and this is the x coordinate next to the angle, adjacent to the angle. So that's how we get the coordinates of C, right? So BC is going to be like our radius, and we're going to take the angle with the horizontal. So the angle with the horizontal of this line right here is gamma, because this is horizontal, right? So it's going to be gamma. So we are going to have the coordinates of B plus BC times cosine of gamma for x and the sine of gamma for y. But how much is BC? Well, from this little right triangle right here, we have that angle beta. We know this edge, right? So sine of beta is this base border B over BC. So BC is the base border B over the sine of beta. So let's get BC. So, no, base border over sine of beta. And now we're going to have XC is XB plus that BC times cosine of gamma and we're going to have something very similar for the y coordinate, except this is going to be sine. So now we are going to change that. It's not going to be B anymore, it's going to be C. Okay, so that's it, and let's switch that back to black. And now let's get those roundings, and we are going to get those by chaining a blur and a contrast filter. So we're going to get roundings that way. But how do blur and contrast work? Well, let's get to these slides. These are the slides from a talk that I gave, and they're going to be linked in the description. And by the way, I've only tested them in Chrome, and they take a bit to load because they're a bit on the heavy side. So just keep that in mind. Now, every element is a grid of pixels. So we can zoom into an element, and I chose this image of parrots because they're very colorful and nice. And let's move on to an area where we have more colors. You can see how we have some blue, some yellowish, some red. Okay, we have a nice mix there. Look at them, so cute. Okay, and then you can see it better as a grid like this. And we're also going to have a second grid. This is going to be a grid of weights. Now, for each and every pixel that we have right here in the pixel grid of the element, right after blur, its RGB value is going to depend on the RGB values of all the pixels around that this grid of weights overlaps. So after blur, the value of the pixel at this coordinate right here is going to depend on the RGB values of all the pixels underneath the grid of weights. Okay, so let's just see a very simplified example. A 4x4 pixel element, real elements are bigger, and a 3x3 weight grid. Okay, so this is what we have before the blur, and after the blur we're going to take things channel by channel, right? So for the red channel we are going to have the weight so the weight at 0, 0 in the grid of weights, that one, times the red channel of the pixel on the first column and first row there. And then we're going to have the weight on the first column and first row in the grid of weights, that one, that 2, times the red channel of the pixel on the second, on the column at index 2, row index 0, okay, and so on, right? And then everything is going to be divided by the sum of weights. So the sum of weights is basically just 1 plus 2 plus 1 plus 2 plus 4 plus 2 plus blah blah, and it's going to give us 16 in this particular case, right? And we do the exact same thing for every pixel in this initial grid of elements, right? As long as there's at least one cell in the grid of weights overlapping one of the pixels in the grid, right? So you can see that. Okay, now one more thing I want you to notice is how here we have semi-transparency for so the alpha channel is going to be 1 if the grid of weights falls within the grid of pixels of the element, right? So everywhere in here, alpha is going to be 1. But when the grid of weights goes outside the element, you can see how the alpha goes below 1. And for the corners, it goes even lower. And if we go like this, right, it's even smaller. And if we, you can see how the more cells in the grid of weights that we have outside the element, the lower the alpha. Now, let's assume that we have an element that's bigger than 4x4 pixels, but this area right here only has black pixels, right? So let's assume that we don't have this edge case where we're at the edge of the element and we have alpha smaller than 1. But let's assume that these pixels right here, they're all black, they're all solid black, 0 on all 3 channels. And around them we have pixels that are white. So that is going to be 255 on all 3 channels. So 255 on all 3 channels. Now, as long as the grid of weights only overlaps black pixels, the result is also going to be a black pixel. But when it starts overlapping white pixels as well, then they're going to start to mix and we're going to get a gray. And when the more of these grid cells are in the white area, the lighter our result is going to be, right? So at the corner, right, it's going to be the lightest result. And this is how we get post blur. So if we apply a blur here, filter, blur, let's say 9 pixels, you can see how it kind of looks like we have a rounding at the corner. This is what it's caused by, okay? Because there are more white pixels to mix the corner black pixels with. So in the case of blurring, the 1 pixel's RGB channels get mixed with the RGB channels of the pixels around it. And in the case of the corner black pixels, there are more white pixels around to mix them with than for those along the edge. So that's the idea behind the rounding. Now, these are a few slides where you just visualize the grid of weights and how much each of these matter in the big picture. So if we move on to 3D, so that's, for example, 400, but here in the corner we have 1, so the weight for the very middle is 400. The pixel in the very middle, that's the one that matters the most, but we still have contributions all around, okay? And this explains how we get the grid of weights. So it's basically the product of a vector with itself. So here we have 1, 2, 1 product with itself, or we can have a bigger vector product with itself. And this slide right here explains how we get those vectors. So we start from 1, and here this 1 is the result of nothing plus 1. This 1 is the result of 1 plus nothing, and then we move further. This right here is the result of nothing plus 1. This is the result of 1 plus 1. This is the result of 1 plus nothing, and then moving further, this 1 is the result of nothing plus 1. This is the result of 1 plus 2, and so on. This is how we get those vectors. So yeah, now one thing you may have already figured out, post-blur RGB values of the pixel are also affected by the RGB values of the pixels around, right? So you can see, and it depends how much, it depends on the blur, because that relates to the size of the grid of weights. So for example, if we have a blur 1 pixel, it's barely noticeable, but then if you go to something like 19 pixels, you can see how it's one big mess. Okay, so let's move on. Let's see what contrast does. Oh, okay. So if we have contrast values that are smaller than 1, these are going to push the RGB channel values to the middle of the 0 to 155 interval. So they're basically going to push them towards a 50% gray. And let me just explain what I mean by that. So this is the HSL model, right? So around the bicone, we have the hue. And if we explode this, going towards the middle, so from the middle towards outside, we have the saturation axis, and from the bottom to the top, we have the lightness axis. So we go from 0 at the very bottom, 0 lightness means black, to 100% lightness, which means white at the very top. And let's look at just one slice of this bicone. Yeah, you can see it here. So if we drop the saturation to 0, then we are on the vertical axis in the middle of the bicone, right? And then the hue doesn't matter. So we can change it in any way, and that gray remains the same. Now, this lightness, if we bring it down to 0, we get black. If we bring it up to 100%, we get white. And a midway gray is the gray at 50%. So that's what we get if the contrast gets pushed all the way down to 0. So we get a midway gray. Now let's see that. We have contrast 100%, or 1 is the same thing. 100% is the same as 1, 50% is the same thing as 0.5, 0 is always 0. So we keep decreasing the contrast. And at 0, you can see how we get the same gray, the same midway gray everywhere. That has semi-transparency, which is why it's looking different. But yeah, for contrast values that are bigger than 1, then the RGB channel values get pushed towards the nearest end of the 0 to 155 interval. And if those contrast values are big enough, then they push the RGB channel values all the way to 0 or to 155, whichever is closer. That means that from a certain contrast value above, we can only have one of these 8 colors. So these are all possible combinations between 0 and 255 on all 3 channels. Okay? Now let's take this. We have a solid background, 255, the red is already maxed out. 155 is closer to 255, so it's going to get pushed up to 255. 84 is closer to 0, so it's going to get pushed down to 0, which means that if we increase the contrast, we are going to get 255, 255, 0. Okay, so, oh, no. I cannot use the keyboard. Okay. So you can see how we got that yellow. Now, let's say here we have a gradient. 255, 0 already at the ends. 153 is closer to 255, so it's going to get pushed up to this magenta, right? Because that's 255, 0, 255. Here we all 3 values are closer to 0. They're all going to get zeroed down to black. Again, all 3 closer to 0, all going to get zeroed down to black. Here we have 255. These 2 are closer to 0. They're going to get pushed down to 0, so we're going to get 255, 0, 0. That is red. And here it's the same color as here. It's going to get pushed down to yellow. So now you can see how we don't have that smooth gradient anymore. We have these clearly delimited stripes. Okay? Now, this one's interesting. So if we have a midway gray and we increase the contrast, what are we going to get? Well, the thing is, it's not the same gray everywhere. So for example, here, all 3 values are 128. They are closer to 255, so they're all going to get pushed up to 255, giving us white. Here, all 3 values are 127. They are closer to 0. They're all going to get pushed down to 0, giving us RGB 000, which is black. Okay? So any kind of gray is going to get pushed to either black or white. If it's closer to white, so above the 50% gray, it's going to get pushed to white. If it's below the 50% gray, it's going to get pushed down to black. So that's pretty much what we have here. So we go from black to white, and everything that is below the 50% threshold gets pushed to black. Everything that's above the 50% gray threshold gets pushed to white. Okay, so let's just see a really tiny example of that. So here you can see how we have again this blurriness, okay, and we go from black to white, passing through all these grays. And if we increase the contrast, you can see how we have just black and white. That thin line is just a glitch. Okay, so let's do that. Let's say that we are going to, and actually we're going to want this blurriness and the rounding, we're going to want it to depend on the viewport size. So we are going to have something like this. We are going to have a relative size in the extra big viewport case. So this is going to be 1.5. So here we're going to have right, so we're going to use that there, and here we're going to have a calc. So calc, and it's going to use that relative size, of course, times 1m. Okay, and now we are going to have a blur value, and this is going to be, let's say, 6. And now here, when we have the blur, we are going to use calc, that relative size times the blur value times 1 pixel. And one thing that I've noticed works well is when the contrast value is 3 times the pixel value of the blur. So contrast is going to use a similar calc, except we're not going to multiply with 1 pixel, we're going to multiply with 3. So yeah, we are going to have a second blur value for something else, but for now you can see how you get that. We don't like that blurriness spilling outside, so we are going to set overflow hidden there, right? And we are also going to get a rounding that's going to be like a base rounding, which is going to depend base rounding, and this one is going to depend on the blur, so it's going to be calc. We are going to have to take into account the base border width plus twice the blur value in pixels. This is just something, again, that I noticed out of playing with this stuff, so it's not derived from anywhere, it's just something that I noticed works well in practice. So that relative size times the blur value. So that is going to be the rounding, so let's set here border radius, base radius, okay. Oh, yeah, 2 pixels. Okay, so we're going to use the same for the button. So let's say we're going to have here button, right? And we are going to border radius, base radius, right? We are going to have border solid base border white, and we're also going to have line height 4. Okay, and something else that we are going to do is create those stripes. So that stripe gradient, it's going to be a linear gradient, and let's decide upon a gradient angle. So this gradient angle, let's say it's going to be 135 degrees, and we're going to need to interpolate that, and then we're going to have so basically the first 3 colors, right? And let's say that we're going to go up to 25%, 0, 50%, and then 0, right? And we're going to use that right here. let's see it. Yeah, if I could spell things right. So it looks pretty good. Now we're going to add this stripe background on the after pseudo element. So we're only going to have this blurriness on the before, and on the after we are going to have background stripe. Okay. So for some reason it doesn't seem to work, or maybe it's not showing. Maybe the before is showing on top of it because of okay, yeah, the before was showing on top of it because of the filter. That was the thing. So now we have that background for the after, and we want to combine it with what we have on the before, right? So we want to limit it to the black areas of the before. To do that, we're going to use blending, and I also have something on blending right here. So blending is basically combining two overlapping layers into one, and it's done pixel by pixel. Here, for example, we have pixel at column index 7, row index 4 in both layers, right? These two pixels at column index 7, row index 4 get combined, and we get a blending result, right? It's done on a per channel basis, at least for the blend modes that we're interested in, and we only care about multiply and screen here. We use percent channel values. 0 is always 0, 255 is 100% or 1. Everything in between becomes a value between 0 and 1. So for example, 220 is 86% or 0.86, 20 is 8% or 0.08, right? And for multiply, we simply multiply the channel values. So let's say that this is the red channel. We multiply the red channel of the bottom layer with the red channel of the top layer. Now, one of our layers, the before, only has pure black and pure white, which really simplifies this computation, because if we have pure black means 0 on all channels. If we have pure white means 1 on all channels. Anything multiplied by 0 gives us 0. Anything multiplied by 1 doesn't change. So basically, if a layer's pixel is black, the result pixel, the corresponding result pixel, is also black. Anything multiplied by 1 remains unchanged, obviously. So if a layer's pixel is white, the corresponding result pixel is identical to the other layer's pixel. Okay? So let's see here. Wherever we have black in this one layer, the result is also black when we overlap the two layers. Wherever we have white in this layer, the result is the other layer when we overlap these two layers. Okay? Now, for one layer being just pure black and pure white, the result of the multiply blend mode is identical to the result of the darken blend mode. Darken always takes the darker channel. So darker channel means smaller valued channel. 0 is always smaller than anything. Black is always darker than anything. Okay? Any channel value is going to be at least as big as 1. So it's always going to be, any pixel is always going to be darker, or at least as dark as white. Okay? It's going to be at least as dark as white. So the result of darken and multiply when one of the layers is just pure black and pure white is the same. Okay? Because the minimum between 0 and anything is going to be 0. The minimum between anything and 1 is going to be 1, because all the channel values are in the 0-1 interval. Now, screen is the opposite. Okay, we have the formula here, and if one of the channel values is 1, then this here becomes, this second part becomes 0, and the result is 1. So if a layer's pixel is white, then the corresponding result pixel is also white. Now, if a layer's pixel is black, so we have 0 for one of these channels, then we get this this part becomes just 1. So we just have this 1 minus 1 plus minus and minus give us plus. So we get the other channel value. Okay, so if a layer's pixel is black, the result is identical to the other layer's corresponding pixel. So you can see here, wherever we have white in this layer, the result when we have overlap is also going to be white. Wherever we have black in this layer, the result when we have overlap is going to be the other layer. And for one of the layers being just pure black and pure white, screen is going to be identical to lighten, because lighten takes the lighter channel value and or the higher. So everything is going to be lighter than black. White is going to be lighter than anything. Okay, so that's pretty much it. So now going back here, we're going to have mixed blend mode, and this is going to be screen or lighten. It doesn't matter in our case. And I think that if I add the mixed blend mode, I don't need yeah. And as I said, lighten works the exact same way in this particular case, where the before layer is just black and white. Okay, now we are going to want to cut out that white part right there, and we're going to do that with a mask. Now we could use a conic-gradient mask, a conic-gradient right there, right? So let's say that all the way up to 360 degrees minus alpha, because that angle right there is alpha. So we can take this, we can start from minus alpha and go for an alpha, and then we can have everything else transparent, or we can start from here, right, and go to 360 degrees minus alpha, and then we are going to have something solid. It's the exact same result. Okay, so we could have a conic gradient there. So let's say mask conic gradient at transparent up to like this. Okay, but I don't like that that jagged edge right there, and it's not so obvious. But if we change the background here, so let's say that we have like this, the jagged edge becomes more obvious. You can see how we have smoothness there, but that edge is jagged. Now for linear gradients and for radial gradients, I just add a tiny value. So let's say, for example, minus 1 degree right there, and then I'm going to have this plus 1 degree. But this doesn't really solve the problem, because we still have a bit of jaggedness there, and then we have blurriness there, and yeah, no, that's not what we want. So a conic gradient isn't a good idea. A better idea is a linear gradient that passes through that corner. Now, how do you get the position of the stop for a linear gradient? So linear gradient, and let's see about the angle. Now, in this case, the angle of the linear gradient is going to be equal to gamma, and it's going to be equal to gamma because look at this. So the gradient line is going to be perpendicular onto this line of change between transparent and solid red. Okay, so the gradient line is perpendicular onto that. The vertical is perpendicular onto the horizontal, which makes up an edge of this angle, right? So we have two angles with edges perpendicular. They're going to be equal. So the gradient angle is going to be gamma. Okay, and then we're going to have transparent red. But what is the stop? well, let's not add it for now. What is the stop where we have that sharp transition between transparent and red? Well, it has to be a line that passes through that corner. So how do you compute that? Well, more than 8 years ago, I wrote my first article, and here you can see we have the y-axis, the vertical axis, which is the angle, the gradient angle start axis. This is the gradient line in blue. This is the 0% line of the gradient, so it passes through the corner and it's perpendicular onto the gradient line. And this is the 100% line of the gradient, passes through the corner and is perpendicular onto the gradient line. Okay? So how do we get the line, the position of the line that passes through a corner like that? Well, so that's our line. We know the angle right there. And drawing a perpendicular right there, this SI segment is going to be equal to this AD segment because these are all perpendicular. We have a rectangle there. So yeah, we need SI, but AD is the exact same thing. Now in this right triangle, because that's perpendicular, in the right triangle ADP, right, we know AP because we know the bottom edge, that's the base width, and we know this angle, so we can get this edge. So this edge over the hypotenuse AP gives us sine of our angle. So basically we have that base width times, sorry, so like this. And you can see again we still have that jagged edge. So we are going to have gradient stop position. So like that, and here we're going to have calc -1 pixel, and here it's going to be the same thing, +1 pixel. And you can see how we have a smooth transition. Maybe we can decrease that and, I don't know, have a smaller error. So for example, here we're going to have 0.5 pixels. So yeah, that's, let's say that it's going to be gradient error okay, better aligned. And now let's get rid of that ugly red right there. But still, let's leave it for a little longer. You can see how there we want a rounded corner, but we don't have rounding there. So what are we going to do? You can see here it's rounded. So we're going to want the same rounding that we have there at the corners. For that, right, that OE, that's going to be that base radius that we've computed, right? Now we can compute those angles. Now this is a vertical line, this is another vertical line, this diagonal line crosses them both. These two angles, so the sum there and this one, they're going to add up, the interior angles are going to add up to 180 degrees. So where was that? So right here, so you can see an absolute value, this angle right here and this angle right here, they add up to 180 degrees. The sign also takes into account the direction, but you can see how we move them, and you can see 62 plus 118, right? 65 plus 115, 40, 140, they add up to 180, right? So here we are going to have that the delta is going to be half of 180 degrees minus alpha, right? So if we draw perpendiculars onto those edges of that angle, right? So that's going to be 90 degrees, right? Then the line connecting is going to split this angle into two equal sides, okay? So, and that's because these two right triangles, they're the same. This edge equals this edge because they're both radii of the rounding, and this edge is common, which means that these two edges are also equal, which means that the angles are also equal. So this angle equals this angle equals this angle equals this angle, and they're all going to be delta. Let's compute that. So it's going to be half of 180 degrees minus A0, which is alpha. Okay, and then we are going to need to get we're going to compute the coordinates of D, the coordinate of O, which is going to depend on D. So let's see it. XD is 0, YD is going to be, so we can get it out of a right triangle. So for example, this edge right here over this edge right here is going to be tangent of that gamma. So this edge is going to be the base width times the tangent of gamma. So the y coordinate of D is going to be the header height, which we know, minus this edge right here, which is the base width times the tangent of gamma. So the header height minus the base width times the tangent of gamma. Now the x of that O point is going to be the base radius. The y coordinate of that O point, the center of the circle that gives us the rounding, that is going to depend on the y of the D point, right? And we are going to subtract this edge in this right triangle. Now we know this edge right here, right? We know this angle right here, right? So tangent of this angle is this edge that we know over this edge right here. So this tiny edge right here is going to be that base radius over the tangent of delta. So Okay, now the problem here is that this is a calc value, so we're going to need to interpolate all that stuff. So and put it all inside a calc, interpolate the tangent as well. Okay, so now we have the coordinates of that rounding, and now we also need, so we only need a background of this size right to here. So we need this little piece right here. Well, that is going to be the base radius minus this OF edge, right? And this OF edge is going to be the hypotenuse times cosine of alpha, right? So it's basically going to be not okay, that was, yeah, no coconuts here. Okay, but the thing is, no, that's right, but that's the base radius as well, you can see. So we can bring out in front that base radius, and it's going to be times 1 minus, and we interpolate this part as well as the base radius, and we put it all inside a calc. So like this, and now we are going to add here, so we're going to have not conic, radial gradient. Radial gradient, circle at 0, base radius, right, and we're going to have transparent up to base radius, red 0. We're going to tweak that part, and then we are going to have position horizontally 0. Then we are going to have the y coordinate of the center, so that's going to be YO, and then dimensions, we are going to have the size along the x-axis, and then we can just use the base radius down. Okay. That doesn't quite look like what I had in mind, I must say. Okay. No, yeah, it's the other way around. So base radius horizontally, 0 vertically. Okay, that looks good. Okay, and we are going to have no repeat. Okay, now that looks much better. And we are going to change the order of these two gradients, and we are going to use mass compositing in between them. So more exactly, we're going to use the subtract mass compositing mode. So basically, this subtracts, this is the alpha of the bottom layer, this is the alpha of the top layer, right? So wherever the alpha of the bottom layer is 1, so wherever we have red, right, the result is going to be transparent. And also, wherever the alpha of the top layer is 0, the result is also going to be transparent. So now we're going to have mask composite. Subtract, we don't even have autocomplete for that. But now you can see it, we have the rounding, but we have a jagged edge right there. So we are going to use the exact same thing that we used right here. Except, of course, it's going to be base radius, right? And now we have that smooth rounding. Okay, that's good. So now that we've done this, we can go back to our normal background. Okay, so we have that, and we're going to have a margin, which is going to be negative at the top. So we're going to have the base border 0 and twice the base border at the bottom, because we want a bit of space before we get to the button, right? Okay, now I want to arrange this gradient a little bit more, because I don't really like where those stops are. So let's say we're going to have something like 29 and maybe make it even 30. 56. So something like that. You can see how, yeah, maybe make it even 31. Much better. Okay. So yeah, no, maybe not that big. Okay, I think I'm going to leave it at that. And we also have another gradient right there. So you can see it. And it's a bit different because this color is darker than that one, okay? So how do you get that? Well, we could get it with a linear gradient, but then how do we prevent it from crossing that one? Or we could get it with a radial gradient that's at some point right there, right? And we start from 6 o'clock, that is 180 degrees. We go to the gradient angle that we have right here, because we want this line parallel to this one. So the gradient angle that we have right there, minus 90 degrees. Okay. And then we go all the way up to alpha, and then we have transparency. So we are going to, that's going to be a point that's symmetrical to D in there. So we're going to have that gradient. Okay. So basically the point symmetrical to D. Let's see it. Conic-gradient from 180 degrees at 100% YD the darkest color, and this one is going to go up to and then we are going to have up to alpha, and then we're going to have transparency. Let's see it. And of course, Okay, that looks good. No, that was not where I intended to click. Okay, so we are pretty much done with the before and the after on the plan. Right, we are done with the header. Nothing more for the cost or there, right? Nothing more for the button, but we're still missing some graphical elements. So that arrow, that little triangle, and we are going to get them with the pseudo elements on the footer. So right, they're not going to have much in common. Just let's take care of the after first. Right, let's give it a padding and a background. So after pseudo elements are placed in the grid area at the intersection between the first row and first column. So since it's on the first row, then that's going to push the button on the second row, and that's perfectly fine. Now we want to get that little triangle, and I think it's the same color as the color in the middle, so that would be C1. Let's make this place self center, so it's just in the middle. Let's make it slightly shorter. Let's give it a margin bottom something like that, and let's also set clip path polygon 50%, 0, 100%, 100%, 0, 100%. Okay, that does it. And then we are going to set here position relative, and for the before we are going to have position absolute, and the top is going to get so we're going to position it so we're going to have arrow radius, I don't know, something like that. We're going to see if it's a good size. And let's set a background white. Let's see it. Okay, now we are going to so top is going to subtract, right? Let's also border radius 50%. Okay, and its left position we're going to have two factors here, two complementary factors that will add up to 1, And here I'm going to have k times and here we have the base width minus the base border. So we're positioning it nicely. Now we are going to have, for the background, we're going to have a conic gradient at 50%, 100. And let's see, we are going to have a narrow angle. Let's say that it's going to be, I don't know, 90 degrees. I think that's pretty 90 degrees there. So we're going to use that. And we're going to start from minus half that arrow angle. White and then we're going to have black like that. Okay, so that's one part of it. And then we're going to have another conic gradient. That's going to be so let's say that we're going to have black up to 90 degrees or 25%, right? And then it's going to be transparent, like this. Let's see it. And we're going to offset this by so kind of like that. Okay, and we can decrease the border radius to something like that, even like that. Okay, now let's say now let's say that this is going to be okay, and this is going to so it's going to look something like that. And I'm not sure, maybe somewhat smaller, it's going to look better. Anyway, we're going to have another blur, and this one is going to be 2. So we are going to take the blur from here and use it So something like this, but we don't like how it just goes outside, so we're going to have box shadow, 0 offsets, 0 blur, and so something like that. I think it should be bigger even, because I think we still get a bit of blurriness. Maybe like that. Maybe even just 1M for that arrow. Okay, that looks much better with 1.5. So yeah, that was a lot of just tweaking stuff. Now you can see one thing I don't like, this thing isn't responsive. So let's take care of that. So we're going to have some other relative sizes. We're going to have a large, small, right? And we are going to set those within some media queries. Let's actually create a function that gives us the breakpoints. So function breakpoints, and we're going to have that factor, that's basically the relative size, whether it's a min width or max width, and the default is going to be a max width, not a min width. And then also direction. So 0 direction means that they're going to be along the x-axis. So they go one after the other horizontally. 1, so direction set to 1 means that they go one after the other vertically, like they are right now. And we are going to have return. Now, if direction is bigger than 0, so if it's 1, if they go vertically, then we just have to take into account the width of 1. Otherwise, we have to take into account the width of all 3 of them. And we're going to multiply this with the base width, with 1M, and also with the factor, of course. With 16 pixels, and divide by 1M, so you can get the pixel equivalent, right? And then if it's min, right, then it's going to add 1 pixel if it's a min. And also we're going to have a tiny buffer of 20 pixels. So that's basically our breakpoint. Now we're going to have media. Now we're going to have min width. So breakpoint extra. It's obviously a min right there, so we're going to use that. It's the horizontal direction, okay? And then we are also going to take into account the extra sizing for the other direction when they are one underneath the other, right? So that's going to have okay, now let's So the relative size is going to be so here we're going to have max width, and it's going to be the smallest one when they're all on the same row. So this one is not going to be a minimum, and it's going to be on direction 0 as well. This one is like this. It's direction 1, okay. And then now this one is going to use something like this. So it's going to have an end there as well. So it's going to be max, there's no min, large, and there's a min, but direction is still 0. This one is going to be extra, it's a max, so it's 0, but the direction is 1, and this one is a large and it's a min, and again that's a large. Then we have another one, and here we replace large with small, and extra with large, okay. And let's just get the body out of there and set display flex, okay, like that. Let's get rid of that gap for now, and let's also have, so we are also going to set another media query for the change from row to column. So that's going to be I cannot use a keyboard. So no min and no direction, okay. Flex direction column, no, that didn't work. Flex direction column. Okay, so let's see it. Okay, so this is the biggest size, then it's going to shrink, and then shrink even more, and now, okay, then we also need to have a line item center for this. Then it's going to shrink even more and even more, and yeah, because we set it like that, but we can change that, and we can have, let's say, 0.75. So let's see, now when it shrinks more, and then even more. Okay, so okay, now you don't get that blurriness outside. That's good. Okay, so now let's fix a few little things. So here, so they're in the middle, okay. Now here for the plan, let's collapse and make it not hover. It's going to have transform scale 0.9, and here we're going to have transition transform, right? So okay, so when we hover them, now there's one more thing that's missing, and that's the shadow right there at the bottom. So how do we get that? Well, where's that article? So I had an article right here where I explained how to do this without using a pseudo element. We've already used up our pseudo elements on the plan element, right? So we do it with a radial gradient in the transparent border area, and the rest of the background is restricted to the padding area. So this segment right here explains it in a lot of detail how to do it. So we are going to have, for example, plan border. Let's say it's going to be maybe even bigger, something like that. Okay, and here we are going to set it border solid plan border, right? Okay, that messes up the border radius, so we're going to need to add that up as well. So interpolate that and have it all in a calc. Plan border plus. Okay, and it's going to be transparent. Okay, and we need to restrict this background to the padding box. Okay, but the thing is, we're going to need another gradient, so this is going to have to become a linear gradient. Like this, and then we're going to have radial gradient, closest side. We don't even have autocomplete for that. I don't even know. We're going to start, the hue and saturation don't matter when the lightness is 0 and we have black, let's say something like that, and we go to transparent, 80%, let's say, and here we are going to have position 50%, 100%, and the size is going to be 100%, and vertically it's going to use the plan border, and we're going to have no repeat. Yeah, also border box. Okay, so you can see how it's starting to look like something. We get that horizontal scroll bar because we've added the border to the width, and we only took into account the width when creating those breakpoints. So we are going to set a margin minus plan border. Right, so now it looks better. I still think that's too much. So something like that. I'm going to leave it at that. I'm not going to tweak it any further. This video has already been long enough. I hope you've made it through it. I hope you've enjoyed it. I hope you like the work that I've been putting out for the past 10 years. And if you do and you want me to be able to do more in the future, please consider supporting it. You can do so by being a cool cat and becoming a patron on Patreon, or if monthly support is not your style, there's the option of a one-time donation, or you can make the stray cat happy with a birthday gift. The links for everything are going to be in the description, including all the resources mentioned throughout this video, and I'll see you next time. Bye!